anniversary celebrated. And so this is the first TV structure for that. So there will be a lecture first, it's third, featuring the same computer with and also always for you to get to know the persons behind each of the ones. As this is also the first content there will be a lot more. And that will be announced as time goes on. A lot of the celebration will happen between February to June of this year. But do expect a series of so for today, I'd like to welcome Dr. Fernando Siringan. Welcome. He is professor here at the Humanitarian Institute Faculty of Science and Technology. And you mentioned Siringan has extensive and broad interest in Asian and social theology, and has from local and national institutions related to social studies and literature. He has been a key figure in submarine groundwater discharge research in the country. And ladies and gentlemen, Dr. Siringan. Magandang umaga sa lahat. Pagkakas ko siya lahat first year sessions. A series of lectures by the Anderson. So even among the faculty, we will get to know what we're doing, the science that we're pushing for MSI for the entire country. And then so that the students and researchers of MSI will also be able to have an idea of what the other laboratories do. There is a tendency for us to be like cave people, only concerned with what we're doing. And it's nice to know what the other groups are doing and to look for ways by which we can work together, try to expand our effort and try to expand our influence. And hopefully, I will be able to convince you that submarine groundwater discharge is a good area for people to converge, for researchers to converge. I got involved in submarine groundwater discharge about well less than 2 decades ago. We worked in Lingendo with the animal models, with Assessor Villanueva. And I was asked to look at the potential contribution of groundwater into the Lingendo, not by the rivers, but as direct discharge of groundwater. At the time when I did that work, I didn't know that it was called submarine groundwater discharge. We did not get to publish, but the report was made available online by Reuters. And Bill Burnett and Makoto Taniguchi, who are pioneers of FPV work in the world, saw that report, so they decided to come over and talk and try to explore the possibility of doing SPV work in the country. And that will be part of the story that I will be presenting to you in a while. Now, if this would work, but it won't work. So if somebody can express it for me. But what is submarine groundwater discharge? May animation ito. Do you want to work? Did it work? Yeah. Okay. SGD is the direct discharge of groundwater across the seafloor, not through rivers, not from regular runoff going into the ocean. And a question that I can now pose to you here, if you are to do a freshwater budget of the ocean, what do you consider? What do you bring in, compute for the freshwater budget? Typically, you would ignore SGB. If you are to account for the nutrient budget, you will find out later on that SGB is a major contributor of nutrients into the ocean. So there's something that is missing in the accounting. There is something that is missing in trying to understand what we're looking at, and that is SGB. And SGB is comprised of meteoric water, fresh rainfall that percolated into the ground, and then it actually found its way across the seafloor. It's part of SGB. And it's fresh water. But you can also have chlorine water. This is water that is trapped in the sediments from years of deposition, but eventually it would be squeezed out and would be released across the seafloor. That's part of SGB. And then you have recirculated seawater. Seawater that will be pumped by waves going inside and then out. And as it moves inside the sediments, the physical chemical characteristics of that water will change. Because then it will interact with the sediments and it will interact with the organisms within the sediments. It can be driven by waves, the pressure itself. It can be driven by tides. It can be driven by seasonal changes. Oops. Where did I take this photo? I think this photo was taken in a plant during low tide. And this is the intertidal area. So during high tide, you don't get to see this. But during low tide, then you see springs oozing out across the intertidal zone. That is part of SGB. Now imagine this taking place in the subtidal area from the shallow subtidal all the way to the continental shelf, a deep area. So it's contributing water, it's contributing materials into the ocean. Okay, I just have somebody stationed here so you can help me with the present. Which is probably about to retire this time. John, can you just do this policy direction? So just go ahead and press please. Everybody don't ask you, press please. Okay. Well, I've mentioned this already, but there's a new term here, pollutant. It is also a pathway of pollutants. You have development over land, You have a set page, and there's a leak in that set page. That leak will eventually find its way into the ocean via SGD. It may occur as diffuse over the seafloor, so it's not noticeable, but it may also occur as a spring, where you see water oozing out of the seafloor, or you may see particles being pushed by the water coming out of the seafloor. Next, please. I would argue, and people have actually shown, that SGD is a significant discharge process. Significant because any portion of the coastline, any portion of the intertidal or subtidal environment. And it's significant because they occur whether rivers are there or not. And therefore, if there are no rivers, then they would become the dominant source of nutrients for that part of the coast. Next, please. And it is typically people would say it is unseen, or we just ignore it. We might be seeing it, but we're ignoring it because we don't understand what it is. But it is true that in the subtidal environment, it is difficult to detect SUV. And that is why part of the talk this morning is to relate to you what are some of the ways by which we can detect SUV. Next, please. And it is not an unusual process. Next. Potential impacts of SUV. They change the biogeochemistry of the nearshore environment, and therefore they can cause algal blooms in Florida. They cause the Carillia brevis bloom. They can influence the seagrass distribution. This has been shown in Europe. And part of the presentation today is to show you that they do influence the coral reef community. Next. In the Philippines, it is expected that SGD is prevalent and at high magnitudes. Hindi siya pakonti-konti lang, kundi maramihan large discharges taking place across the seafloor. Why? One, because we have steep coastal gradients. The hydraulic gradient is a major driver of SGD. You put along the permeable materials before water, it will sink its own level, it will travel down and be discharged across the seafloor. The steeper it is, the more efficient the system in pushing fresh water out of the permeable material. We have a lot of permeable materials along the coast. We have limestones that have been fractured or perhaps have undergone karstification. We have a lot of pebbly coastlines, sandy coastlines. We have very young volcanic materials that are permeable. We have high rainfall. And because of that high rainfall, part of that rainfall seeps through the ground and becomes part of SGD. And then part of what will be discussed, presented to you today, is hydrothermal activity. This is a major driver of SGD, and we have a lot of volcanoes in the Philippines. Next, please. Well, how do we detect SGD? One way is by looking at salinity. But salinity is not a reliable indicator of SGD. So people have used isotopes. One of them is radon-222. In other countries, they use radium, different isotopes of radium. Then some people employ what is called electrical resistivity profiling. We send a very low voltage current across the water. It travels through the water and then bounces back. And the electrodes would measure the time it took for a signal to travel through the water column and across the subwater. And part of a serendipitous discovery is that people use acoustics. We can use relatively low-cost acoustics in identifying and mapping SQD. Next, please. This is from Bolinao using seabird, CPD. This is just about 4 meters in depth. And you can see the units here at PSU. This is 332382, 332412. We tried doing this work with the YSI, and we occupied many stations. We did not see any change in salinity as we go down. But that's because of the resolution of the instrumentation. So we went out with Kay and with his fans, basically Seabird, Fernando. There's relative freshening. There's very small freshening. But it means there is a very small amount of fresh water that's incorporated into the circulated seawater. And that's enough to change the chemistry of the water coming out. This 4.0 depth is the seafloor. So imagine for those studying organisms, benthic organisms, well, how would SQD influence your benthic organisms? Next, please. This is in Manila Bay. This is case data from 2008. You cannot remember anymore. He's also retired. Okay. This is surface salinity. Okay. And the salinity values are shown here. This is, we have a river coming out through here, and you get some freshening. But this is salinity distribution at depth of 12 meters. And here you see a lowering of the salinity. We know that there's a spring beneath this area. So salinity can be in SGD can occur in shallow water, SGD can occur in deep water. Next, please. Well, one of the tracers that we're using in the Philippines is radon 222. At the moment, we do not have the capability to use radium, the budget, kung meron mang tiga-DOST, bigyan po ako ng radium. Pang-detect ng radium. Well, why can we use radon 222? This is a natural isotope. Okay? It's one of the products of the series of disintegrations, transformations of uranium 238, which occurs naturally in rocks. And with water, with rocks, it then takes that radon, and then it becomes part of the SQD. And radon has a half-life of only 3.8 days. If you go out to the open ocean, take a sample, very likely you will detect zero radon. But in the coastal area, not near a river, you may get some radon, but away from rivers, you can still get radon, and the source of that radon would be SQD. It is enriched in groundwater. It is inert. And so what we do is we look for places with high radon concentrations. And this is the device, say RAD 7. It's years ago, this was 250,000 pesos. Okay. And what we would do is we can do a spatial survey, move along with the boat, pump the water in. The water would go out here, the air would go out, and then we suck the air and then bring it into this device. And so by doing that, we can identify places with high radon counts, and such places would be the places with intense SGD activity. Next, please. So we did that in Bolinao in 2008, and we went along every 30 minutes. We would get a reading. Okay? So we just took this route. Okay? And this is 0, the very small dot. As it gets larger, the more radon you have in water. This is salinity. Okay, you can acquire several information through a through flow system. Well, what this told us is that, well, so there's this potential of having a lot of SGD taking place right along the reflat of Santiago. So then we embarked on a study of SGD within the Santiago reflat. Next, please. Well, part of what we did was to look at resistivity. And we take advantage of the fact that different materials have different resistance to the flow of electricity. So these are different materials, and these are their relative resistivities, and shown here is that of seawater. Okay, the resistivity is very low. Kaya madali kang makuryente, you get electrocuted easily. Much easier with seawater. And this is fresh groundwater, and we have a slightly higher resistivity. Now combine that with the resistivity of the host material, and then of course the resistivity will go a little bit higher. In general, the resistivity is higher if the same sediments are bathed with fresh pore water, and resistivity is lower if what we have is saline pore water. Next, please. And so we do this tag along, pulling a long cable, sending electrical signal, and that electrical signal gets received back by the electrodes, and this can penetrate down into the sediments, giving us information about what's happening in the subwater. Next, please. The data would look something like this once we process it. So the reddish high resistivity, which can be due to the pore water or it can be due to the material itself. The white line is the seafloor. And across that seafloor, you see some of those red and some of those blue lines. The blue ones are with low resistivity, they cut across. And the interpretation is that, well, we have water that is moving back and forth across the seafloor. In places, the water is low resistivity and therefore likely to be seawater going in and then going out. In places where you have this reddish, yellowish bands, those would be places where likely you have some fresh water coming in, getting across the seafloor. Next, please. So we did that for the Santiago flat. We occupied several lines, combined it with radon data. The squares here are stations where we grabbed samples and analyzed the radon content. And the bluish ones are those with zero radon. And as you move towards red, it's red right there, you have high radon. Practically, with this survey, we can say that in many places or in most of Santiago, SGD is taken care of. And that was confirmed by the resistivity value or the resistivity survey. This is Fenn's diagram. This is one of the ways by which we can do analyze the three-dimensionality of the area. The white line is the seafloor. Above that is the water column. Below that is the subwater. And here we see patches where even underneath the seafloor, you get a lot of blue resistivity. Blue resistivity being lower resistivity. There are also places where we have reddish yellowish getting across the seafloor. So that would be places where you have relatively fresh water going across the seafloor. So we can identify these places would be mostly recirculated seawater, but in some places we get input from brackish water. Next, please. In Malindat channel, this is a blow up, and you will see this again later on. Again, you have this reddish material spreading across the seafloor, but you also have in this portion lower resistive gauges moving across the seafloor. Part of what will be shown to you later on will be the coral data from this place based on the thesis of Nico. Yes. So, next, please. So the other way of mapping SGD is using acoustics. This is a transducer. It sends the acoustic signal, it would receive the acoustic signal. And the nice thing with the acoustics is that they've developed relatively low cost instrumentation that will allow you not only to determine the water depth, but also have some sort of a photo mosaic of the seafloor. It's just like a multi-beam, which is multi-million. This device, if you buy it in the US, it's 1,000 US dollars. If you buy it in the Philippines, it's 2,000 US dollars. Well, such is life. But it's this panel. This is the top deck unit. Okay, you get to see what's underneath using acoustics. Okay? And one of the things that we did not intend to look at was to look at SGD in a study in Batangas. The study was for mapping active faults. But the active faults, they occur all over Batangas. So when we did the survey, we passed through an area with a lot of bubbles. And then serendipitously, we image next, please. So this is a picture of the bubbles moving across the seafloor. And those bubbles are not just bubbles, they're not just gas. The bubble itself moving out of the seafloor induces the circulation of seawater. So anywhere that we'll see gases being emitted from the seafloor, there is a portion of that seawater being recirculated into the sediments and then back out as SG2. And this is a down imaging profile. This is the seafloor right here. This is the water column. This is top bottom. Okay, with this device, we don't get to see much information about the sub-bottom, but we can see the seafloor, we can map that. And then there's this anomalies across the water column. And where we found those bubbles, they are this anomalies. So we were able to map areas with bubbles being degassed from the seafloor. And those are also areas where the circulation has taken place. Then we found out that all these gases, based on the study of Cardenas, it's 99.4% CO2. And it's part of the hydrothermal activity that's taking place in this area. This area is volcanic in nature. Talumpan Peninsula. This is an image of a spring with a lot of bubbles, but with a lot of water coming out as well. And this is the acoustic image. You see this, it's like a tower, but the base is like hollow, and then there's gas on top. So we can identify bubbles, we can identify bubbles with the potential of having a lot of water mass emanating from the seafloor. Next, please. And because of that, I had a student who worked on this for her thesis, Elrose Gubuyo, so we got that published. And we're hoping that people will pick up on this technology because it's relatively low cost. Yes, please. Well, what do you do when you need a sample for analysis? Well, we need to go down, and what we do is we make a flow. We put down a drum, salt off drum, and onto the sediment so that it will trap the water that is coming out. And then we have this outlet. We put in a plastic bag. But since we work in an area with a lot of gases, we had to provide for an outlet for the gas so that the plastic won't flow. Okay? So then the water that gets trapped in the plastic can serve, number one, we can measure the flux, and then we can get a sample for chemical analysis. We can also get a sample for microbiological work. Next, please. The first formal SGD work that we did was in Manila Bay. This was with Makoto Taniguchi and Bill Burnett. And it came out in 2008. The work was done at the foothills of Mount Maribeles. Next, please. So we laid down seepage drums across the subtidal area from 1 meter to about 3 meters, about 12 drums. We also did a survey, resistivity survey, which is in situ. And from that, the net result, next please. Well, we learned that SGD of Bataan is mixed SGD. The average salinity of the seawater outside of the drums was 32 PSU. The water that was collected from the drums had an average salinity of 28 PSU. So that's a lowering of 4 PSUs. It's telling us that there's a lot of fresh water that is being moved across the seafloor mixed with the circulated seawater. Next, please. We were also able to measure the seepage rate, and we'll just use this value right here on a per drum basis. And we were getting something like 13 liters per day. Try to remember these values because we will compare the seepage rate in the other sites. Next, please. So dissolved inorganic nitrogen in seawater, 3.8 micromoles. In the seepage water, 55.3 micromoles. In Manila Bay, based on the report of the Acetus group, average is 4.2 micromoles. And the rivers coming in, 10 micromoles. Now, compare that 10 with 55. The question, of course, is the overall flux. So we did the flux calculation. Next, please. What we did was, so we studied just a portion of Manila Bay, and then we made the big jump and said, well, what if what's happening here is also happening all along the coastline of Manila Bay? And when we did that, this is what we got. The seepage water accounts for, or is comparable by 42% of the contribution of Pampanga River, and almost matches the contribution of Pasig River. Well, what this is telling us then is that, well, if we're not accounting for the contribution of SGD in our nutrients, we're underestimating our nutrient level. Next, please. We did a study, a similar study in Sorsogon Bay. This is pieces of Erwin Navasa. And the Sorsogon Bay is here. It's also volcanic. This is the specific sampling area. Next, please. Looking at the flux or dissolved silicate, 37% of the river input. And we think that the reason for this was because when we did the sampling, kakaputok lang nilulusan. So there's a lot of dissolved silicate available to the river. But we look at the phosphorus, 268% of the river input. The nitrogen is 182% of the river input. Again, we are underestimating to look at budget if we're not looking at SBD. Next, please. We went back to Bolinao with the radon, with the electrical resistivity survey, and basically these are the conclusions. SBD is prevalent on the replat. You can basically say it's all over, and taking place all over. It is mainly recirculated. So seawater coming in, seawater coming out, driven by waves, driven by tides. But there are places that have faults or faults pass through them. And across those faults, we get mixed submarine groundwater discharge. In the follow-up study of Senao and others, next please. Okay, with this follow-up work, these are the things that we found out. Next. Okay, we did some sampling here, near bottom samples. We also did time series analysis of Silaki. Okay, next please. Nutrient values of ambient, that is seawater, and compared with the seepage sample, they are comparable. So you can say, there's not that much nutrient coming in. Well, that's fine. But still, there's some nutrients coming in via the circulated SBD. Next, please. The nutrient values are in general comparable to other reefs elsewhere. And so nothing unusual taking place in the Santiago Reef. But there are points where the nutrients are 1 to 4 orders of magnitude higher than the animal. And these are the places where you have faults cutting across the reef line. Next, please. In general, then, SGD serves as a widespread source of nutrients on the reef line, but there are certain locations where you have concentrated input of this nutrients. Next. The average that we measured from Santiago Reef Line is about 8 to 11.5 centimeters per day. Remember a little bit, 5.1 centimeters per day. This is recirculated seawater. There's a lot of water being exchanged within that or across the seafloor. Next, please. Danica Manzanigo, this is her dissertation. One of the things that we wanted to confirm was SGD limited to the reef line? Or is there still SGD taking place beyond the reef line? Two, we wanted to confirm the idea that faults serve as pathways of brackish water. And so that was the main intent of this chapter of Danica's dissertation. Next, please. Well, we found out that, SGD occurs in the reef line, everywhere across, along the reef line. Two, that we were able to confirm that faults are conduits of relatively fresh SGD. Well, what did we do? We used PR and we used radon. Next, please. Okay. So this is the electrical resistivity. This is the seafloor. Again, a lot of blue lines, no resistivity cutting across. But there's a lot of reddish lines cutting across the seafloor. SGD with greater freshwater component is widespread along the northwest reef front of Santiago Reef Line. Well, why did we go there? Well, we went there because this segment or this front is a little bit unusual. Typically, reef fronts are rugose, very irregular. But this reef front is very linear. And so we hypothesized that, there must be a structure cutting across that front. And the ER data, in some ways, confirm that. Next, please. Still in prep after 2 years, baby muna, Danica also used remote sensing images to map thermal anomalies. The basic idea is that SGD in carbonate platforms will deliver relatively cooler water. Next. So she generated regional SST maps and identified potential SGD sites across the carbonate areas. She estimated SGD clusters using radon, and she also, next please, estimated the regional SGD clusters from these two data sets. And what came out of this work, next, is this. The SGD flux is anywhere from 10 to the 9 to 10 to 11 cubic meters per year. The discharge of annual labor is 10 to the 10. So it is from 10% to more than the flux of annual labor. And the enclosed areas of this irregular polygons, those are the places where thermal anomalies were detected. Next, please. So, well, SGD, represented by the cold SST, is pervasive across the carbon platforms. Next, please. That and the SGD's potential flux tells us that it is an aging process that should not be ignored when you're doing work in carbon platforms. Next, please. This is in prep based on the thesis of Nico Garcia. This was resurrected during the APCRS. But the basic idea that came out of this is that SGD type can vary over a very short distance within a week. The work is in Malinap, comparing the east side and the west side of the Malinap channel. And basically, it says that the SGD type influences storm cover. Next, please. So the work was done across Malinap channel. And on the eastern side, we have some brackish water coming out. The western side, it's mainly recirculated seawater. There's of course temporal variation to this. Okay? But this is data acquired by the Nico also acquired his own data. Basically, it says the same. And so we found out then, next, Nico did some transects across the area at depths of 700 meters. Next. In terms of the overall benthos, there is not that much difference between the east side of Malinap and the west side of Malinap. They both have coral cover. At the time when this work was done, roughly around 42%. But if you now look at the details of, well, what are these corals? Next, please. Then it would, this is what Nico got, that in the area, the eastern side with mixed SGD is dominated by Helioptera, up to more than 80%, while the west side, which is mainly recirculated SGD, it had lower Helioptera quality. Now, looking at the soft corals, you see a similar difference. If you look at the Seractinian, you see a similar difference. So the question then is that SGD? So what we did was to sample the Helioptera, the most dominant Helioptera, next, and did some isotope work. The west side, the east side, okay, had some slight variations in the nitrogen isotopes. Typically, when we have heavier isotope values, we would associate that with some pollution. And that's what we're seeing in the skeleton of Helioptera. So we're convinced that SGD influences coral cover in Malinap. It is not necessarily the reason why Helioptera is dominant in that, okay, but it certainly influences the distribution of the Helioptera. Next, please. We go back to Opini in Batangas. This is work with other members of MSI. Carol Harula is our program leader. My wife is here. She's part of the project. Van is the one looking at models. There are other faculty helping out, Cesar Villanoy, Rachel Butanco, Irene Villasenor, and Irene Rodriguez. Irene, I'm sorry, it's the second time. So there are a lot of people involved in this, and we're trying to pull in more people, and hopefully through this presentation, some of you will be encouraged to join in and look at SGD in a hydrothermal element. And ito malapit lang mag-iwan. So again, this is a hydrothermal induced submarine groundwater discharge. Next, please. So there's active volcano, volcano, a lot of inactive volcanoes. The study area itself is inactive volcano. In fact, that was explored by EDC, Energy Development Corporation of the Philippines, for potential hydrothermal hydropower generation plant. So this is the specific area what we did. Specifically for my aspect, the geophysical aspect, we mapped the SGD using acoustics. We sampled the water to estimate the flux, and we also tried to look at the geochemistry of the water. Next, please. Again, the different types were identified, and they were mapped. The types of SGD, sparse, curtain, spring. Based on the images and based on the side scan, we were able to map the substrate type, the sandy portions and portions that are gravelly or even with outcropping rocks. So it helped us understand that in places where you have a lot of springs and you have a lot of curtains, they typically occur in places where you have faults that can be projected offshore, and where the faults tend to converge. Those are the places where you get a lot of this. And elsewhere, you can have this widely distributed over the study area. Next, please. And Tiffany came up with this map. This is geology, so okay, and then we did the distribution of the substrate here, the different types of substrates, and then we overlay this on top of that. This would be the type of SGD. So we know where the types of SGDs are taking place and what substrates they're associated with. Next, please. So we acquired water samples using the seepage drum. Next, please. And this is what we got in terms of the rate. This is in liters now. 137 to 4,591 liters per year. Do you recall some of the values from earlier? This is 2 to 3 orders of magnitude higher. And this is because of the hydrothermal activity. Next, please. If we now use the lowest flux, spread that over the map area, which is roughly 60 kilometers by 0.2 kilometers offshore, that gives us a discharge equivalent to around 10 to the 7 cubic meters per year. Now you might, maliit, it's small. Huh? But in this area, there are no perennial rivers. The rivers are ephemeral, seasonal land, only when you have rainfall. So then your dominant source of nutrient would then be SGD. Next, please. In Sorsogon Bay, The small rivers there, ito lang yung flux nila, 1 times 10 to the 5. 1 times 10 to the 7, just for that itty-bitty area, is 2 orders of magnitude greater than river. Next, please. So, with the help of Jack Cadella, her lab, and her 10 major students, these are some of the values that we got from the seepage water. Average pH, 6.2. So that's the water that is being delivered across the seafloor, very low pH. But in that area, you still see problems. So a question for the bio people, well, how are they doing? How are they surviving? How are they able to calcify? Another exaggeration is also very low. The threshold is 2.8. This is the seepage water. Okay. Phosphate, relatively high, 2.59. In the work of Carol Haraula and her students, there's a lot of iron in the water, there's a lot of sulfur, and Ox's work looking at microbes, just they were able to detect a lot of sulfur degrading organisms. Yes. And then there's also a high magnitude of arsenic. Now, dissolved silicate, which is something that I'm pursuing now, 236 plus minus 200. Mataas ito. This is high. Next slide, please. This is global data from different SGD studies. Okay. Terrestrial SGD, if you have fresh water coming out, different rock types, and the amount of dissolved silicate that one can get from the SGD. And this is a recirculated SGD. Now, again, in Mabini, it is mostly recirculated SGD. Okay? But you look at that value, or even look at complex lithology, okay? We're getting samples that would give us more than 500 micromoles of dissolved silicate. So there's a lot of dissolved silicate. So the question then of biologists, the surface water of the ocean is depleted, with dissolved silicate. So, sino makikinabang who will benefit from this very high discharge of dissolved silicate? We've done some initial, my interest with this led me to taking a lot of pictures of what I thought were asparagus and sent them over to Cecile. Of the 20 pictures that I sent her, all of them turned out to be silicious. Question that I have now is, will that high input of dissolved silicate influence abundance, diversity of silicious using organisms, or those organisms that have to eat, say, diatoms? One time, I told me a story about the growth of Bertana cucumbers. In one place, they're so slow growing, and the other place, they're fast growing. And I told her, well, why don't you check SG? Next, please. These are compilation of the results thus far from different study sites. And Mabini stands out very high. Now, this is a hydrothermally induced SG. Next, please. And these are my ending slides. Active, potentially active, and inactive. Even if they are inactive, they still have warmth underneath that can induce hydrothermal activity. We have a lot of faults cutting across those volcanoes. And those faults can be pathways of water that can interact with whatever is down there and then eventually come out as an SGD. So So what we're looking at in Mabini is not unique. I think it's all over the country. So there's opportunity for people based in different parts of the country to look at this type of SGD. Next, fallen, ophyllite. What is an ophyllite? It is a sliver of oceanic crust that has been emplaced on top of the continental crust. But they undergo weathering. The process is called serpentinization. If the olivine, which is a mineral in the ultramafic rocks of ophylites, react with water, one end product is that of serpentine. But the process itself is exothermic. It produces heat. There are springs in El Nido. There are no volcanoes there, and yet there are hot springs in El Nido. It's likely that it is the ocean crust underneath that is undergoing serpentinization. And that serpentinization is producing the heat that is needed to produce the hydrothermal activity. The other thing that is interesting with serpentinization is that they produce methane, not CO2, but methane. And the question is, well, if you do have places like this, what would be the associated? There are studies in the Philippines, but terrestrial. There are no studies yet in the marine environment. But this map shows us that there are so many places in the Philippines with ophylites, and they continue offshore. And the last cruise in the Bank, coming back to the mainland, Hazel and company did a survey in Aurora. And there is this place where we know on land where there's ophyllite, and then you have the coral reef, and then the land bubbles come. No volcanoes in that area. So, is that because of certain. So there's a lot of potential work that can be done. There's a need for people, for students, to look at SGD, and certainly they should not be ignoring SGD in their work.
So the floor is open for questions. So pwede ba the opposite, that you see that there are places that are not yet mapped that have faults, but if you see bubbles and then they are more CO2 than measured, can you then surmise that there should be therefore fault lines along those areas?
Yes. If you're able to map, say, the linearity of features, then that would be indicative of faults. But not only faults, people have used the mapping of gases as a way of identifying volcanoes, submarine volcanoes, and be able to infer. You sample the gases, and then you can infer something about the activity of that volcano. And we are in a place where we have so many volcanoes. So the question that I would throw to people is, well, do we have submarine volcanoes? But there's no exploration taking place. And there's limited data on offshore active faults.
So yung nangyaring earthquake sa Bohol, di ba, unmapped fault, tama ba? Unmapped fault. So that could have been, similar features could be found as well.
Yes, in Bohol, it was in 2013 when that earthquake took place. On land, there's a displacement that was seen in an area that they have not identified on the whole from previous works. And then two, that if you project the linearity of that fault, it extends offshore.
Is it possible to tap energy from these features?
Well, we look at methane. Methane, we have methane flat rate from the pathogenesis of organic material, and they get buried underneath the sediments at a certain temperature conditions, certain depth. They become ice. You might have heard of the methane flat rates. Um, they can be imaged seismically, and we know that there are bottom simulating reflectors offshore of the western coast of the Philippines. So likely there are methane flat plates underneath in the sub-bottom. They can be good, they can be bad. With subtle change, it might be good, because then you keep the pressure. Okay? But if you get a lot of degassing, it can make the seafloor unstable, and it can lead to landslides or submarine slumps. Okay? But elsewhere in other countries, they're looking at methane graphite as a possible source of fossil fuel in the near future. The technology is not with us because they are deep, deep water, and deep subwaters. But with the progress of technology and with depletion of the known reserves of fossil fuels, other countries are actually looking at the potential of using methane plants. And we should do the same.
I saw a hand related study.
Number one, it seems creating a technology for SGD is difficult. But it's quite a big task. There's so many things happening to tackle. And we can show so many different things. Do you think that that's really important work and how far out you guys I don't know about ecology and all. Okay, that would help people like biologists also get to understand that. Because there are many other things that drive them into discussion right now. And that this one answer has been made. I will answer that. Well, so first is do consider in the report that SG is in whatever form it's taking place. It's there. Two, if we want to have a handle on the SG in your study, there are certain tools that can be used. You can use acoustics if you're in an area where there's a lot of degassing taking place. Darwin, for example, is an area with a lot of degassing. So you can use acoustics, which are really cheap. You can RAD 7, if you have a budget nowadays of about $1 million pesos for RAD 7. It's the cost of RAD 7. CTD, how much is a good CTD? Million. That doesn't seem much sense. What about the measurement itself? You can go down and acquire near bottom samples and have them analyzed and compare it with water taken just about 1 meter above the seafloor. The difference can be due to that damper flux. You can trap the water. The seepage meter is relatively cheap. So a lot of people go out, dive, just swim around with you, like some water. And then you can have a good handle on the type of SUV that is taking place here. Semi-long,
Ibang tanong? Yeah.
So, from your studies, what are organisms thriving and these characteristics of what are some of them. And we also translate the results that organism thriving in regions, areas that are also affiliated as information.
It depends on the nature of the SUV. If you're referring to a region where the pH is much lower than the average ocean water, where the bottom temperatures are much higher than the typical temperatures elsewhere, then yes. In fact, I think there is a program elsewhere that is looking at those types of benthic organisms that are able to adapt to those conditions and how we might be able to use them to repopulate other sites. So there are ongoing studies elsewhere, and that is one of my hopes. And the work that Van and her students have done a lot already, and I believe that they start thinking of how to utilize them for such purposes. A previous program led by Manu looked at ocean acidification. So the lens that was used for that program is ocean acidification. Our student, Michelle Reyes, published a paper that looked at the coral cover of Tinglo. Although the pH of the water oozing out is very low and it's warm, but in the nearby areas you see a lot of corals. And that's also the area where there's a lot of sponges and a lot of soft corals.
We can prioritize
Yes, I think one of the deliverables of the program is to be able to recommend to the LG some sort of having an MBA. But Mobini is already relatively protected because of the industry. Their livelihood is tourism. And so people are doing well. So tourism in this case is helping out because then people don't do a lot of fishing that can damage the coral. And they know that it's their asset, so they're also protected. But I think they have not yet declared formally Parasite as an activity.
We have some questions through Zoom.
So from Alvin Elgado, currently know about the significantly higher flux from hydrothermal induced SPE. And we say that this type of SPE is a priority area for coastal and MPA management. Is this already communicated to stakeholders?
The last question communicated to stakeholders more. Hopefully soon in the program. The question of should it be prioritized or not? I think there is value to different environments, but it's something that we should appreciate and not just focus on one because they serve a purpose. In fact, one of the hypotheses that we have coming into this program is that SGD in general, is helping biodiversity. Well, why is that? Let me qualify that. You have SGD that's cold, so it may have low biodiversity, a certain set of organisms. This is warm, another set of organisms. But they're different, and they're within the same area. You combine them. Well, that has biodiversity. warmer by 10 degrees, warmer by 5 degrees, warmer by 30 degrees. In other places, colder by 5 degrees, colder by 10 degrees. And then you combine that with chemistry. You have this full range of chemistry. And different organisms will thrive in those conditions. But of course, certain organisms cannot live in those conditions. But you combine it, totality, different environments, different organisms within the same area.
I have millions of questions, but maybe other I love how as a geologist you're making your field with biology and biodiversity. I hope the students retain that. No? But my question is, me and my students, we've been trying to do coral restoration and speak in the Bolina system for almost half a century. And that's how old I am. So, but then when it's very frustrating, and when we started to talk about FGD, so I had a master's student at the time, the doctor, he's a PhD. I said, that's the things. That's why our coral transplants are always dying. Okay, so if you are doing coral restoration, and I don't know if there's anyone here in that line of work, I don't see better facts. And there's significant SGBD input. Don't bother. So that's the direct link to sort of people management. Now, the other thing is, went back, was just finished with the we're trying to identify coral restoration, and then in the middle of that area, there was a wave of chromosomes invading the system, which know, and biology like anthropologists, they kind of lowered the they know both the limitation conditions. So they were invading along that area. So they did not get to the cell because I think there was this barrier of GP acting as kind of a wall, preventing the chromosomes from invading the entire reef flat of Santiago Island, otherwise all over the yan. That's all I want. Thank you. I'm sorry. So again, the here will continue to work, especially in the Lino area where we have a lot of baseline. So of interest also is the change, no? Over time. These are very time scale changes in the station. But over longer periods of time, would there be like a significant change over time? Because the other lens is to look at ecosystem changes on all levels, from really small all the way up. Because it's an important driver in that we flat. So maybe that was one of the reasons where there's broad patterns distribution. And on the other hand, well, I was talking about this, we've got aspects of invasive species. No? Kasi water, salinity endangered talaga yung karamihan ng very successful invasive species that are able to, go from the brackish area near the estuary. And now we have reports in the island. So hindi ko alam if it's partly a stepping stone. I don't know the idea that we're thinking. But it's something we should watch out for. Baka dati wala. Pero now, bottle char, we have the black chin, black tilapia, and that's already reported in Bolina. So this situation might facilitate that. Right? So siguro, it's good to know, ano scared kaya
dapat natin itong spatial awareness, especially to the new students, especially the young students. Good enough students there don't lose a lot of money. They have a lot of baseline information, so maybe it's time for us to really focus on some integrated questions, particularly in relation.
First going back to what Helen raised earlier about quality of classification. And within that area, just up there towards the blue line, that was where the nursing was established. And then came a heavy rainfall, several weeks. And eventually that rain percolated down into the sediments. And there are reports of a look in the water, it's wrinkles in the water coming out. Let's say a visual sign of SGD. It's like a mirage, you see this when you're snorkeling or diving. Two, there was elevation of turbidity in the sites where there's SGD. And also a large drop in salinity that migrated over the nursing. This was reported by Shams and company. I think it's a 2010 paper. And in fact, that's the reason why the lab was able to acquire the RAD7. The RAD7 disappeared on my door. So I won the RAD7 boom, courtesy of Dr. Ed Gomez. 2 years before that incident, he encouraged us to write a proposal so that we can be integrated to the GDF program. But it did not pan out. But his question then was, well, what do you need to do your SGD work? And I told him, well, the basic tool would be to have a RAD7. So although we never got to be included in the GDF, there was this manna from heaven, a gift that right at my doorstep, the RAD7, and we're still using it more than a decade after. Two, in the comment, a question raised by Annette. Can there be long-term changes? Yes, there can be long-term changes. Since it's driven by change in precipitation, if we have an overall change in precipitation, then one can expect to see changes in the SGB as well. Two, if there is a change in typhoon activity, that can also influence SGB. This is something that they demonstrated in Taiwan, looking at hydrothermal vents. Earthquakes, if the SGB with brackish water component prefers to move along faults, but the fault moved, then that fault motion can either open up new conduits or close certain conduits. And this is a known fact for people looking at very deep ocean environments, exploring for oil. They have seen old communities and new communities. The old communities, it's abandoned because the activity of methane emanation shifted to a different site because the fault became closed. And the fault opened up elsewhere. So it can change different times with different conditions.
May tanong pa yata from Zoom.
So probably within Journal, can we use the Regan method to distinguish the influence of a riverine versus SGE on faunal species distribution in the reef flats or coastal area?
Well, it's on how you use the equipment. If it freshwater from rivers will, of course, they will just flow. And so you take water sample from the upper portion of the water column, and you see freshening, and at the same time high radon, that's probably input from rivers. But if you take a sample from near bottom, and you're able to work out the salinity profile, then you can rule out river input from that of SGB.
Related question, 1, 2, and 3. Yes. Go ahead. Go ahead.
Related dun sa sinabi niyo yung sa yung 2 points, yung share plot, yung last of this question. First point, yung meron akong work in 2015 na 10 kilometers yung side. Pero the basic ecology measure parameters were kind of like different difference. So possible na SGP, I don't know, influence yun sa part ko na anda. Yung second point ay meron kami mga sites sa anda na minsan init, minsan malamig, may provide kami. And may mga areas na may yung thermal, although may river, pero minsan may makikita na after few days meron tayo. Last, ang third question ko ay meron tayong map po or meron tayong work sa anda in terms of mapping of especially sites because I will be doing some work in SGD in the next few years.
For ANDA, for the last carry, you can check on distribution. Should have fourth and two, it's good for those doing one-time physical chemical measurements. If you're doing work with water, it varies over time. It varies over time. Kaya kailangan madami yung measurements mo. And then it's not just in one area, you have to have several so that you can understand what's happening. Right? And that is not, I'm not saying that to promote the physical science of trauma. But it's definitely something that you do so that you will understand the lateral and temporal variation so you can make the right attributions on the reason or reasons for those lateral and temporal changes. But in saying so, I'm also emphasizing the fact that make use of the opportunity of being at MSI where you have physical science people that can be tapped for such studies.
Okay, go ahead.
I tell you, don't be a superman. Don't try to do everything on your own. Work with people who can help you. Have an agreement on how it's to be done. I know people who try to do it on their own, everything, but the science of getting able to do is not. Mas maganda you work with people who have done it for so long, and they can explain things in one thing, one look. They can explain things to you. Something that you will have to ponder on for months, it can explain one or chapters.
May question ka siya?
Idadagdag ko lang ang relationship sa isa kasi tinitingnan is there's time duration. So you say physical science one particular parameter. So for short time scale, there's the concentrated cycle computation waves are up. And I think for the large scale variation important to look at is the fixing motion due to seasonal variability inside the wind pattern. At the same time, one important parameter to consider is the variation theory. So using the example na some area of research na pwedeng tingnan ng galing student natin, pwedeng eventually the organism can try to.
So, yun yung kanina, no, yung gusto mong trabaho ng aside from seasonality, make sure you're not tidally biased. Diba? Huwag 8 o'clock every day. Kasi that doesn't mean anything. Sundan nyo yung tide. So, if it's high tide every time, you're gonna measure it's high tide.
So, my question is more about the methods of acquiring samples. So is there, how do you maximize efficiency of acquiring data? So do you follow like maps or like fault lines, or do you map out the classes first? Like, how do you efficiently acquire data? For example, if you have such a large area, so like how do you know that these are the areas that are delivered value? You want to acquire the least efficient way of doing it is doing it blind. And that's why we have to do mapping first. So that we get to see the variability. And then you have to ask the question, well, what do I want the sample for? It's where you would sample, when you sample, how to sample will depend on the questions that you are trying to answer. We know that there's a lot of variability on the seafloor, and you can have diffused SGD taking place, but then you can have concentrated SGD in one place. If your question is, well, I would like to compare the two, well, then you'll have to sample both. But since you've done it, you know exactly where to go. If you're studying organisms as well, then you know where the organisms are. Then if you want to relate what's happening with the SGD with organisms, then you'll have to sample it close to where you have your organisms. Or the other thing you can do is try to look at, well, where would the water move with tides? If I follow that tide, I can do a sample along the shore, and therefore I can look at the gradient of influence. So, I would encourage that you do your mapping.
From every material. In northern Mindanao, there are SGDs and seem to promote more soft corals. This possible. And next question, what would be the impact of SGDs on the plankton apart from possible have promotion?
The first one, I think provided people can better answer that. So we're not pretending to do just a little wanted but the second one, I can answer that. Diagrams will thrive in areas with a lot of input from resolved citizens. And then things will follow. There are studies by Japanese SGD researchers that they were able to show that in SGD sites, they have a lot of fish in terms of abundance and diversity. But this is not in a coral reef area, this is over a sandy substrate. And then when they sample the fish, they open the guts of the fish in the SGD sites. They saw gametes. And then it turned out that gametes eat diatoms. So I'm doing a simple chain. So in fact, marami pa tayong hindi alam, kaya mag-aaral lang. We're trying to come up with a training manual or a manual for doing this work. And hopefully that will be out before the end of the program. If you can pay your way to Mabini, Batangas, we can feed you, but not everybody. We will conduct training on SGD work.
Question number 2 out of millions and millions. So, not that I was inspired by the interventions of the others about temporal scaling. So, this is a food for thought. When we have elevated, that's bad news for at least coral. So, how do you then correlate the population of, say, Santiago Island, increasing human population density? And we all know, all over the coastal areas of the Philippines, they don't have sewage treatment at all coast. So if you're swimming happily on coastal waters of the Philippines, you're actually swimming in sewage. So, and then has this been increasing over the years, lalo na the nitrogen enrichment of the water, which will percolate into the matrix of your coral reef and whatever other substrate you have. And so the detectors over time, and this is correlated with the increase in human population density. Lalo na that. So,
Not from our own work, but from the literature. They were able to document the difference in the nitrogen input between populated areas and places with very few people. That indeed, yes, the SE will carry more nitrogen. And they were able to document the serious effects of this high nitrogen input. There are a lot of researchers in Hawaii that's doing as to the work, in particular, they're looking at the biological aspects. The time series, there are other researchers elsewhere doing that. In the Philippines, we have not done that type of work yet. Hopefully, somebody can pick up on it, do it. Right now, the work that we're doing in Mabini, yung pinaka-time series namin, halos 6 na. We cannot make conclusions in terms of increasing nitrogen input as we do in time. I think for that, you can face as a proxy, and you can go to an area with almost 1,000, but similar, and then go to another area, similar setting, physical chemical setting, but with a lot of people, and then do something else.
Just additional comment from Helen's question. So we did this research in Boracay where we collected, 30 centimeter sediment core in an area where we think there's SGD. And the difference in Boracay is we have much more porous bedrock. There's also fault run through there. You have, of course, SGB freshwater that also passes through a lot of populated areas. Within this short sediment core, it has shifted the delta 15 and the nitrogen isotope value of the sediments. So I think it started from 1 per mil, then towards the top, 5 cm on the core, which is the present day populated area. It shifted to 5 per mil. And this is bacterial signal, enriched nitrogen isotope, common to, in that area, we could associate it with sewage, and which also correlates with our E. coli, total body hormone, caffeine, and other pharmaceuticals. So, yes, they get sediments are really good reporters. Maybe we could also catch that delta 15N signal in the coral, except that we don't have coral samples. But yes, it gets into the sediments. It's reflected there. It's the fabric, the biogeochemical fabric is affected. It's just we need to get the right tools. Thank you.
So I would like to thank Fernando being here and I'm here. So once again, see you Monday. See the next for is
There's coffee and chocolate over here. So if you guys can just bring your nuts. Here. Sorry. That's easy. That's not. It's too many.
We're taking the
For